Welcome everyone. Today, we're diving into the critical topic of risk monetization. Often, in the industrial world, we speak about equipment failure in technical terms, vibration, wear, or cycles. But at the leadership level, decisions are driven by dollars. My name is Santosh Raikar, and in this session, we will explore how boards and management teams can convert technical failure exposure into clear financial decisions, creating a bridge between reliability engineering and capital allocation. When directors sit in the boardroom, they are asking a fundamental question: what is the actual financial value of the risk we are carrying in our assets right now? If a board can quantify complex metrics like margin, cash flow, and enterprise value, they should certainly be able to quantify equipment risk. Monetization allows leadership to compare a reliability upgrade on the same economic footing as a supply chain shift or a market expansion. The thesis of this presentation is simple. Qualitative labels like high or critical aren't enough for capital decisions. By expressing failure in money, we create a shared language. This isn't about replacing engineering judgment with a calculator. It's about strengthening that judgment by making the stakes visible to finance, operations, and the board alike. Our agenda today covers 6 key areas. We'll start with why this matters to executives, move into how failures translate to financial loss, outline a practical valuation framework, and then discuss how to drive action. We will wrap up with governance strategies and some illustrative case studies to see these principles in action. Let's start with part 1, why this matters. We need to understand the why before we get into the how, specifically looking at why boards should care about monetized asset risk. Qualitative language often fails to trigger action. If a reliability lead says a pump is high risk, finance might see that as just another maintenance request. But when we convert technical exposure into economic visibility, we close the communication gap. When the value at stake is visible, decisions move faster and become much more defensible. What does a board really need to know? They need to know which assets pose the highest financial threat, how much of that risk is being actively managed versus ignored, and which investments offer the best risk reduction return per dollar. Ultimately, they need to know if the residual risk, the risk left over after we've acted, fits within the company's appetite. Failure risk destroys value in many ways, some of which are often overlooked. Beyond just the repair bill, we see lost production margins, quality rework, energy waste during unstable restarts, and even strategic erosion like a damaged reputation. To truly monetize risk, we must look at this entire spectrum of value erosion. There is often a disconnect in reporting. Plants typically report downtime hours and budget variance, technical metrics, but boards need the value of lost capacity and the economic value of mitigation. We need to move from reporting what happened to reporting the financial exposure of what could happen. When we look at an asset risk portfolio, it becomes clear that risk isn't uniform. Usually, a few critical systems dominate the enterprise's exposure. Monetization isn't about making everything equal. It's about making the portfolio visible so leadership can focus on the big hitters, much like they would manage a financial investment portfolio. In part 2, we will look at how failure actually becomes dollars. We'll explore the mechanics of translating technical risk into value erosion. The basic logic is straightforward. Expected annual risk equals the probability of failure times the consequence value. While we need data and judgment for the inputs, the concept is easily understood by any executive. Our goal here isn't mathematical perfection, but rather economically useful prioritization. A major failure is rarely a single cost. It's a stack of consequences. If you only look at the repair cost, you are systematically understating the risk. In most cases, the largest consequence layer is actually the production margin, the money we didn't make because the machine wasn't running. This chart illustrates how an engineering outage cascades into a shareholder issue. By showing how a technical event impacts margin and cash flow, you strengthen the justification for intervening earlier. It turns a maintenance problem into a business protection strategy. When calculating consequences, consider these categories: throughput loss, repair costs, quality scrap, safety and regulatory fines, and even secondary damage to nearby equipment. Don't forget the soft costs like expedite logistics and the damage to your reputation with customers. One of the biggest mistakes is using maintenance cost as the only denominator. If you only justify projects by how much maintenance budget they save, you're missing the point. The real value is in avoiding production loss and volatility. Risk monetization shifts the talk from spending less to protecting more value. We can even modernize the traditional risk matrix. By giving each zone a financial meaning, we help leadership compare safety risks, operational risks, and asset risks using a common monetary lens. It remains a visual tool, but one that now directly supports resource allocation. However, expected value isn't the only lens. We also need to consider tail risk, those low-frequency but high-severity events. Even if their annualized value seems moderate, the worst-case scenario might be enough to threaten the enterprise, so these deserve special visibility. Now let's move to part 3, the framework. I'll walk you through the 5 steps to actually calculate monetized equipment failure risk. Step 1 is defining the asset and its function. You can't value a risk if you don't know what the asset does for the business. Is it a bottleneck for capacity, a utility supply, an environmental control? The functional consequence must be explicit. Step 2 involves defining failure modes. We don't just value the pump, we value the seal failure or the bearing degradation. Different failure modes have different probabilities and different recovery times. So being specific here is key to an accurate valuation. Step 3 is estimating likelihood. We use history, inspection data, and engineering judgment to place failures into likelihood bands. The best models are transparent. They allow decision makers to see and challenge the underlying assumptions. Step 4 is estimating the consequence. We look at the duration of the outage and the impact on quality and safety. To avoid false precision, it's best to define ranges. What is the best case, the most likely case, and the severe case? Finally, step 5, convert it to money. Sum up all the cost categories: output, repair, safety, and so on, while being careful not to double count. Multiply the total by the probability to find your annualized risk exposure. A key takeaway is that as our controls improve, our monetized risk goes down. This allows the board to see risk reduction as an economic return. We are managing control maturity as a lever to create or protect value. Using bowtie logic, we can see that preventive barriers reduce the likelihood of a loss, while recovery barriers reduce the severity. Risk monetization helps us put a price tag on each barrier, turning a technical discussion into a quantified action plan. Where does the data come from? You need to pull from the CMS, finance reports, and EHS records. A common challenge is that production loss is often recorded as revenue instead of contribution margin, or that safety risks are hard to monetize. We use the best available data to inform our bands. A word of caution: avoid false precision. The board doesn't need to see a number like $4,327,912.83. That looks fake. Ranges and scenarios are much more credible. The goal is robust prioritization, not a perfect decimal point. Decision trees can simplify board choices by comparing the cost of mitigation against the expected cost of doing nothing. This is often far more intuitive for an executive than a technical reliability report, as it clarifies which uncertainties really matter. In Part 4, we move from analysis to action. How do we use this monetized risk to actually drive better business decisions? When comparing treatment options, the most technically elegant solution isn't always the best economic one. Boards should look at the risk reduction per dollar spent and the speed to value. This makes reliability choices comparable to any other enterprise investment. Monetized risk helps you decide many things: which assets need redundancy, where to spend your maintenance budget first, and which risks are actually acceptable to defer. It takes the guesswork out of justifying spares or emergency readiness. When presented with a choice, executives should ask 2 sets of questions. Regarding the asset, how much value does it protect, and how fast does risk grow? Regarding the option, what is the implementation cost, and what residual risk is left behind? This approach significantly strengthens capital allocation. Reliability projects often seem optional until their avoided risk value is visible. With monetization, these projects can compete fairly for capital against commercial or digital initiatives. The use cases extend beyond just big projects. You can use this for spare part strategies, insurance discussions, and reviewing whether it's safe to defer a particular maintenance task. It provides a consistent framework for contingency readiness. One of the most powerful applications is in deferred maintenance. By deferring work, you might save this month's budget, but you are creating a visible debt for the future. Monetization reveals this hidden liability, making deferral a business decision rather than just a maintenance one. Risk models only create value if they influence work in the field. High-risk findings should trigger clear ownership and due dates. Boards should ask how these high-level dashboard insights actually travel down to the person executing the work. Without monetization, we tend to chase the loudest failure. Portfolio thinking allows us to ignore the noise and rebalance our attention toward the highest enterprise value exposures, improving both our focus and our results. Part 5 focuses on governance and reporting. How should a board actually oversee this monetized risk on an ongoing basis? Governance starts with ownership. While many departments provide inputs, someone must own the methodology, and someone must accept the residual risk. If ownership is vague, the governance won't be effective. Second, you must document your assumptions. Being explicit about how you calculated probability and downtime allows for peer challenges and prevents bias. Good governance is about transparent logic, not just correct math. Boards need to see residual risk compared to risk appetite. This tells them if the organization is operating in a safe zone or if escalated action is required. It transforms a data exercise into a dynamic decision system. A board dashboard should be concise. The top 10 risks, trends in exposure, and overdue actions. The executive view beneath it can dive into the details like condition findings and the value realized from recent actions. Here are a few questions for directors. Which assumptions drive our top risk values? Where are we intentionally carrying risk? And how do we know this data is actually changing how people work on the shop floor? How often should we look at this? Portfolio reviews are great for a quarterly board cadence. Plant leadership should look monthly at action progress. And of course, any major change in equipment condition or business assumptions should trigger an immediate event-driven review. Watch out for common failures. Don't let this become a finance-only exercise, and don't let models get stale. Most importantly, never allow a maintenance deferral without someone explicitly accepting the financial risk that comes with it. Finally, Part 6 covers implementation and real-world cases. Let's look at how to get started and what success actually looks like. Our roadmap starts with a focus scope. Don't try to value every single valve on day one. Build a repeatable method on a small scale first. And remember that owning the actions is just as important as the calculation. In your first 90 days, select one critical system. Align your teams on how you will value consequences and build your initial risk register. By the end of this period, your top mitigations should be integrated into your normal capital review process. Consider this case: a boiler that seems too expensive to maintain. By monetizing the risk, we see that a single forced outage would cost far more than a year of maintenance. This reframes the board's talk from cost control to value protection. Or take the case of an expensive spare part. It was initially rejected due to inventory costs. However, risk monetization showed that not having it created unacceptable exposure. The spare was then seen as a rational hedge rather than a burden. Finally, consider an overhaul deferral intended to save short-term budget. When the failure likelihood was combined with the potential consequence, the exposure was too high. Monetized risk helped leadership see that the short-term savings weren't worth the gamble. Success looks like this. Reliability is understood by finance. Actions are prioritized by value, and residual risk is consciously governed. We move from accidentally accumulating risk to intentionally managing it. I'll leave you with 5 takeaways. Risk has a dollar value whether you measure it or not. The biggest value is in avoided volatility. And most importantly, the winning model is the one that actually changes how you invest and act. This presentation was prepared for educational purposes. All case studies are illustrative, and I encourage you to use your site-specific data for your own decision-making. thank you to the conference organizers for the opportunity to share these frameworks. In closing, risk monetization isn't about perfectly predicting the future, it's about preparing for it intelligently. When we speak in dollars, reliability becomes an enterprise value conversation. That is how we make better decisions together. Thank you.